So 10 years ago when I started MIST, most of you guys thought I was crazy, and I would say everyone in this room were AI skeptics. Now, how many of you guys saw Waymo, self-driving Waymo Ubers at the airport? How many of you have been in one of those self-driving Uber Waymo? Okay, how many AI skeptics do I have left in the room? Is there any skeptics left in the room? Okay, I would say almost everyone I've talked to now knows AI is going to affect their life in some approach, right? Now, radio resource management. I think, how many people here trust radio resource management to touch their network? You guys all trust radio resource management now, guys. Now, it took a while for that to happen. I would say radio resource management was the first AI assistance in networking, right? And for those who were around 20 years ago, it took a while for people to actually trust it, but I think we're past that point. So I'm here today to talk a little bit about how AI is affecting networking and radio resource management overall. I would say the other question I get is, when did this all start to happen? And I would say if you look at Google Trends, you'll see the searches for deep learning and machine learning happened in 2014. That is when this AI stuff seemed to take off. And the reason why is back in those days, compute and storage got cheap, right? That's when all of a sudden all the cloud, we actually had a place to do it. The other thing that happened is open source code came out available. Right, TensorFlow, transformer models. What we saw were big models become available. Now, I would tell you, we've all been doing machine learning for 30 years. What has changed right now is the models have gotten big. You know, ChatGPT, we're talking about models with 500 billion weights in them, right? These models are on the size of your brain, right? You look at your brain has about 100 billion neurons in it. The other thing that's happened, you know, back in the 80s when I was doing my master's, yes, I did a little neural network. It was a couple thousand weights, right? So this is the big thing that has happened in this network. These networks are getting big and large and trained on large sets of data. The interesting thing is, when you look where they came from, these models came because they're based on the brain. We're actually using these models now to basically look at protein shapes, right? Be able to predict protein folding and understand the brain. So it's almost like a circular loop we're into. The other big change, you saw Dave Coleman talk about using ChatGPT. We're entering a point where we are doing nonlinear, non-deterministic programming. We are learning how to program these agent frameworks. This is going to be transformational in how we program in the future and solve networking problems. We're going to be using these large language models to actually start solving networking problems going forward. It's going to change how we program. It's going to change how you have to test these things, right? These things are not deterministic like our old days. When you wrote code, scripts that did a thing day in, day out, this is going to be a new programming paradigm that we're all going to have to get used to. Now, the thing I've been working on is basically taking, how do I take large language models or take large models, you know, where I take network data and I'm taking Zoom Teams data and I'm training very large models with terabytes of data that can actually predict Zoom Teams performance. And then we're using this, I tried to do a data science class about 4 or 5 years ago. I didn't get many takers on this data science stuff. How many of you have heard of Shapley or mutual information stuff? So this is fancy math that actually allows you to start to determine and rank features in a model. So now we can build models that can accurately predict a Zoom Teams performance, and then we can start to rank how each network feature contributes to that latency, jitter, throughput. So when you start to think about, once I have a model that can do that, what happens when I generalize it? Right? So this is like these large language models. Once I have a large model that can accurately predict your Zoom Teams performance in a network where I have Zoom Teams data, what happens if I can do that out of sight, out of time? And what that means is now I can start to use this model to actually predict the performance on any network, right? You know, as long as I have the network features coming into it, I can start to predict what is the Zoom Teams performance is going to be of a user on that network. Now, interestingly, where this becomes an interesting feature is it becomes another input to your radio resource management. So there are cases now where we had a large retailer in Australia. They were having some problem, couldn't quite figure it out, but it turned out to be it was some narrowband radar, right? The radio was missing it. We weren't picking it up on DFS, right? But the model was starting to pick up that, hey, there's something going on in one of the DFS channels. So this is an example where these large models can start to help pick up little signals that are being missed. And this is what I call the needle in the haystack case. Now, why this is interesting is once you have this model up and running, this is, I think, the next thing going on in networking. Right, 20 years ago, we started to build a lot of things that could actually look at your radio resources and try to accurately adjust channel throughput to optimize interference or optimize something. What we're going to go towards the future is what I call network resource management. Right, there's a lot of other knobs in the network that we need to start looking at beyond just the radio resources. Now, I realize it's not totally relevant to this crowd. We're kind of a wireless crowd here, and everything looks wireless. But I think you all know that when you get complaints, it's usually not the wireless network, right? About a third of the time, there's something going on the wireless, but sometimes it's the client, sometimes it's the LAN, sometimes it's the WAN. It's usually one of those three links getting between you and the application that you're trying to do. So this is what I would claim is really the next step in kind of our radio resource management in terms of network AI assistance is basically, and we're Sadir in the out there. We always have a debate about simple math. Not everything requires fancy math. But the fancy math is, yes, there's Sadir, yes. So yes, not everything requires fancy math. And a lot of things will get solved by simple math. And we've had radio resource management around long before AI, right? So we were able to solve problems without AI. But the AI is going to let us start, the fancy math is going to let us start to solve more interesting problems. So I think that was my main point. Fancy math is coming our way. Let me give a clue here. If I do another data science class, do I have any more takers on data science yet? Are we still, anyone interested in how these models work? 'Cause I tried this last time and I didn't get much takers on this model stuff. Okay, so I may try the data science thing again. How many wine tasters do I have in the crowd? Yes, there we go. I knew that would be a winner. Okay, thank you everyone.